All right, let's dive in to the secret world that makes all our software work. We're going to pull back the curtain on how developers manage just mind-boggling complexity and, keep our favorite apps from crashing and burning into total chaos. Your app is Legion. That's a powerful line, isn't it? It gets right to the heart of the matter. When you open an app, you're not looking at one single thing. No, you're looking at a whole army of different parts, all working together, hopefully in harmony.
I mean, seriously, have you ever stopped to think about it? How do these huge apps with hundreds of features and things to click on all manage to play nice with each other? It kind of feels like it should all just fall apart.
Well, the secret isn't some kind of dark magic. It's actually some really smart engineering. It's a toolbox full of these brilliant, reusable solutions called design patterns. And today, we're going to break down two of the cleverest ones that developers use to keep things sane. So to really get the problem, you gotta see that software isn't one giant block of code. It's more like a bustling city of individual objects, all talking to each other. And as you can see here, even a simple idea like a person or a department can just explode into this crazy, complex web of interactions when the app is actually running. This is where the chaos starts. So let's look at our first major hurdle for any software architect. It's something they call a combination explosion. And yeah, it's as messy as it sounds. Let's use a fun example to make this real. Okay, picture this. You're building a massive role-playing game. You want all kinds of cool character races, and you want to give them a bunch of special abilities you can mix and match. First up, you design your 10 base races. Elves, orcs, dwarves, the whole fantasy shebang. Each one's unique. And then you start adding the cool stuff, special abilities like stealth or self-healing, maybe some super strength. Now, a character could have none of these, or one, or even all of them. And it turns out, with just 4 abilities, you already have 16 possible combinations. Now, here's where it just gets completely out of hand. If you try to do this let's say the simple way, and create a separate blueprint for every single combination, like an elf with stealth, an orc with stealth and super strength, you end up with this, 160 different types of characters to code. It's an absolute maintenance nightmare. So how on earth do you solve that? Well, you definitely don't write 160 different versions of your characters. You use a beautifully elegant solution called the Decorator pattern. And this just shows you the raw power of a good design pattern. Instead of 160 blueprints, most of which are just copies of each other, you only need 14. That's one for each of the 10 races and one for each of the 4 abilities. It's a massive, massive reduction in complexity. So how does this magic actually work? Well, think of it like getting dressed. You start with your basic object, your elf character. Then you just wrap it with a new piece of functionality. You add a layer of stealth. And then you can wrap that with another layer, like super strength. Okay, but here's the really clever part. It's how each of these wrappers changes the behavior. Look at this table. When the game triggers an attack, that super strength wrapper catches the signal, doubles the power, and then passes it down to the next layer. The stealth wrapper, on the other hand, it intercepts the defend command and cuts the damage in half. Each layer gets to add its own special twist. So in the end, you don't have one big clunky object, you have this dynamic chain of objects all linked together. It starts with the newest ability on the outside and goes all the way down to the core character in the middle. It's flexible, it's clean, and best of all, it avoids that code duplication nightmare. Okay, so that's one kind of complexity wrestled into submission. Let's pivot to our second big challenge. This one is all about dealing with complex, nested things, a problem you could call taming the tree. And you see this pattern everywhere, probably without even noticing. Just think about the file system on your computer. A folder is basically a container, right? But what's inside it? Well, it holds individual files, but it also holds other folders, which in turn hold more files and folders. It's this classic branching tree structure. And it's not just files. The web pages we look at every single day, same exact idea. An HTML document is just one big tree of tags. You've got a body tag that can hold a paragraph, but it can also hold another div tag, which then holds even more tags inside of it. So how do you write code that can deal with these tree structures without becoming a tangled mess? You guessed it, there's another beautiful design pattern for that called the composite pattern. The whole idea is right there in that definition. It helps you build out your tree, But the truly brilliant part is that it lets you treat a single little item and a whole group of items in the exact same way. That word uniformly is key. And this right here, this is the light bulb moment for understanding this pattern. A single file, it has a size, right? And a whole directory, which is just a bunch of files and other directories, also has a total size. The composite pattern lets your code ask both of them, hey, what's your size, using the exact same command. Your code doesn't need to care if it's talking to a single leaf or an entire branch of the tree.
So how does it pull that off? The magic word is recursion. When you ask a folder for its size, it doesn't actually know. It just turns around and asks all of its children, every file and subfolder inside it, hey, what's your size? And then it just adds up all the answers it gets back. It is that simple and that incredibly powerful. Okay, so let's just quickly put these two awesome tools side by side. The decorator pattern is all about adding new jobs to an object on the fly, and it does that by forming a chain. The composite pattern, on the other hand, is all about handling things that are made of other things, and it does that by organizing them into a tree and treating everything the same. And that's really the big takeaway. These aren't just some abstract ideas from a textbook. Design patterns are like a master architect's toolkit. They are proven, reusable blueprints that are used to build the complex, yet somehow stable applications that literally run our world. They are the hidden genius, bringing order to all that chaos. And really, it just shows you that there's a whole story happening underneath the software we use. What we see on the screen, that's just the tip of the iceberg. Underneath it all, there's this entire world of elegant patterns making it all work. So it kind of makes you wonder, right? What other secrets are hiding in plain sight in the apps you use every single day?